All right. When we study functions, we like to identify parts where the function is increasing or decreasing. So let's talk about what we mean in those cases. So we're going to let y equal f of x. So if we think about an increasing function, what we really mean is that if we start to the left at x1 and go to the right at x2, that tells us that f of x1 is less than f of x2. So what that means, roughly speaking, is that if I graph this on the xy axis, and I start at x1, which is to the left of x2, then what that means is that the value at x1 is less than the value at x2, whatever this function does. So it's telling us that as we increase the input, the output also increases. So if you thought about this and you said something like, my bank account is increasing over time, what you're saying is as you move into the future, that as you move further along in time, the value in your bank account or the money in your bank account keeps going up. So that's what we mean when we say increasing. And if you look at it, it's basically up and to the right. Decreasing is quote unquote the opposite. And what we mean in this case is that if x1 is less than x2, then that means that the function is not getting larger, but it's getting smaller. And what that looks like in this case is if we draw it up here, again, we have an x1, we have an x2. What happens is we start up here at f of x1, and that's going to be above f of x2. And so this is roughly what we mean when we talk about a function increasing. It's going up and to the right, or it keeps, as you keep moving along in time, it keeps moving up in the y direction. Or if you keep moving along to the right, if it's decreasing, it goes down. So this is down and to the right. And when we ask about where a function is increasing or decreasing, we might have a function that gets split up somehow where it does something like this and comes down like this. And if we look at this and we split it up and we'll call this point, I don't know, we'll call this B, we'll call this A, and we'll call this C, we'll say that on this interval A comma B, that is the open interval starting at A and going to B, this is increasing. And if we look at from B to C, that is the open interval from B to C, it's decreasing. Now, generally speaking, whenever we talk about increasing or decreasing, we always talk specifically about the open intervals. There are tricky issues that come up when we talk about closed intervals that are technical in a way that don't really illuminate things in a good way, but just at this stage anyways. And so just stick to doing open intervals when you talk about increasing or decreasing. That is, you find the x values such that the value of the function is going up and to the right, or it's decreasing where the function is going down and to the right. Okay, so I've drawn a graph here. Let's go ahead and identify it very quickly. So there's the y-axis, the x-axis. If you notice, we have a filled-in point at -1, 0, and then it kind of comes up and then goes back down, and it's going to keep going that way. And just imagine it keeps going down and to the left. And then down here at the point -1, 3, this comes up basically like a straight line until it hits this point 2, 4. So in fact, let's go ahead and label those points. So 4, 2, my bad. This point down here is -1, 3, and then this point is -1, 0. Okay? So if you were to give a graph like this, you could actually identify quite a few things from it. So for example, if we're looking for the domain, what that means is we're looking for all the x values such that there's some y value for it, which means that we draw a vertical line at that x value and we hit the graph somewhere. So if we look at this, we'll hit the graph at x equal to 4, x equal to 3, x equal to 2, x equal to 1. These points are right above each other, so it actually still hits the graph at x equal to -1. And it also passes the vertical line test because it only hits the graph at -1 at this filled-in point. Down here at this open point, it doesn't hit that. What we're saying is that the graph goes all the way up to that point, and then we erase that point. So we only hit it once. And then if we notice, it keeps going left. So then we would write down all the x values. So we'd start at -infinity. 3 is not infinity. It's quite far off. and then we would go all the way right 4. And if we notice, we can't hit anything beyond 4, but we do hit exactly 4. So that's our domain. Our range, if we look at that, that tends to be all the y values that we hit. So if we look at this, so we're going to keep going down and down and down, so we're already going down to negative infinity. And if we keep going up and up and seeing what horizontal lines we hit, we stop right around 2. That's the last horizontal line we hit. So if we write that down, we write the lowest value first, which is negative infinity, and go all the way up to 2. Now, when we talk about where a function is increasing or decreasing, we're just looking for the x values, okay? So we write this down as the set of x values where this is happening. So where is this increasing? Well, we're looking for function parts where it goes up and to the right. So if we look at this, we start at -1, -3, we go up and to the right. Okay, that's definitely increasing right there, so that'll work. Again, we just leave the open interval. Now, if we look at this, you would want to say that this part is decreasing, but if you notice, it's going down and to the left, but that wasn't one of our two options. If you looked at both the options, we're either going up and to the right or down and to the right. And so if we were to track this graph going right, we would notice that we're increasing. So even though the arrow is quote unquote going down, we always think about walking along the graph in a direction to the right, and see whether or not we're going up as we go along or down as we go along. So if we look at this, this is going up and up and up, and in fact, it'll be going up starting from negative infinity until it hits -2. And now if we look at that, it handles all the up and to the right, and if we notice, we turn back down like this. So where is it decreasing? That's going to be between this point right here. The x value is -2, so that's what we choose, all the way to -1. Now, one of the reasons we identify increasing and decreasing is it's actually one of the signs that we've hit what we call an extremal point. That is, we've hit what's called a local maximum or a local minimum, basically either the largest value or the smallest, lowest value that the function can take in some local area. So if we look at this, if we keep increasing, 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 we get up to this point and then we start decreasing again, we'll notice that that's exactly sort of where the function hits its top, at least for this section of the function. So that's actually a signature of where we're increasing. So if you notice a point where you go from increasing to decreasing, that's the sign that you have a maximum. And likewise, anytime you go from decreasing to increasing, that's the sign that you might have a minimum. Now, if we look at this, it doesn't quite have a minimum because we have this jump right here. And its jump actually sort of says that we don't have a minimum because we want to say -1, 3, but the function doesn't actually hit -3. And it keeps getting closer and closer to that, but that's not a minimum. That's not the smallest value you can take because it can't take -3. So that's one of the ways that we sort of identify these things. So keep in mind that you're not just thinking about whether or not the function's going up or going down. You're thinking about whether the function's going up as you go to the right or the function's going down as you go to the right. So in this case, this is up and to the right, down and to the right, up and to the right. So increasing, decreasing, increasing. And that's how you identify these things, by just writing down the x values where those things occur.